So I'm going to be using the FreeSky D4R-II receiver right here, and I'm going to put it in PPM mode and hook it to the PPM input on the BeeRotor right here. So you can see the wire going across there. This wire here comes from this plug right here, and there's the arrow so you know the orientation. So it goes from this plug here over to the D4R, just plugs on channel 1. And then there's a jumper that you have to put on pins 3 and 4 right here to put it in PPM mode. And then after putting it in PPM mode, you have to bind it. So let's just look at the instructions for that.
So this is the setup instructions for putting the D4R-II on PPM mode. So what you do is you jumper pins, or channel 3 and 4 pins right here. That's this little jumper down here. And that will make channel 1 the PPM output for channels 1 through 8. And channel 2 will be RSSI, so I'm wanting to get RSSI on my OSD too. Now just as a side note down here, unless you do the firmware upgrade to the D4R, you'll really only have 6 workable channels. Well, 6 is plenty for me, so I'm not going to do the upgrade. I've only got a 3-channel plane, so 6 channels should be plenty. And I'll still have room for a mode switch and for the RSSI. So it should be just fine.
So Fergie asked me a question about how this controller relates to the NAES32. And I don't have a NAES32 to compare it to, but from what I hear, this basically is a NAES32 with an OSD added on the back. So everything I'm doing here other than the OSD should work with the NAES32. I know this PPM stuff works with it because I've seen other videos where they hook up the D4R to the NAES32 and do this exact same thing. And as far as the OSD, you can still put the minimum OSD on the NAES32. You just need to connect it externally, and then basically it programs the same way. It just uses a different firmware, of course, but programs the same way using the FTDI cable, which I have right here. This one just happens to have the FTDI connector right here on the board, whereas you'll have it on the minimum OSD externally with an NAES32. But other than that, it should be very, very similar. This one does not have a mag on board. I think some NAES32s have a mag, but again, I don't have one, so I'm not really sure. But this does not have a mag on board, and that's good, so that I put my GPS compass module that has a mag built in. I don't have to disable the mag on the board, which would involve cutting an etch or something. So really this is set up for an external magnetometer. So that's about all I know comparing it with the NAES32. So I hope that answers that question. Okay, let's go ahead and bind the D4R-II. We've put it in PPM mode with this jumper right here, and we need to bind it to tell the system, the radio system, that it is in PPM mode. Okay, so let's go ahead and do that. Go ahead and turn on the Taranis. Okay, the Taranis is actually already on. So now I've got a model already set up in here, so I'm just going to press the menu button once. Now we're in the menus, and I'm going to hit page once, and now we're in the model menu. Let's go up to the channel mode right here and get it on bind. So you can see here I have D8 and channel 1 through 8 set, and I'm going to put it on bind, and when I'm ready I'm going to press the enter button. But first I got to hold the button down on the receiver and power it up, and then I can press the enter button. Okay, so I'm going to go ahead and do that. Now it's a little tricky because you have to hold the button in like this at the same time you plug in the battery. You almost need 3 or 4 hands to do it, but I'm going to try it here. Okay, plugging in the battery, and now I'm going to press the bind button, or press the enter button to start the bind process right here. And it's going to make that sound. And then when the receiver starts blinking over here, you know you got a bind. So now I can just hit enter again. And that should get it. Now we can just power down the system and turn off the radio, and we should be in PPM mode.
So now that we got the BeeRotor plugged into the USB port on the computer, let's go and work with Cleanflight. Here's Cleanflight. Let's go ahead and connect like that. Now let's look at the configuration, and you'll see I've already got it set up as a plane right here. I did that earlier. You can select what you want, like if you got, say, a quadcopter, you might pick quad X, or if you got a flying wing, you would pick flying wing. There's other options in here available, but I got it set up as an airplane right now, and I've already saved it down here. So now let's look at what else we got to do. Now we're going to be using PPM, so let's go ahead and select RX PPM input right here. Put that on, and we'll just look down here. I think the current sensor, I've already got that selected earlier and put 500 in for the scale. Some recommend 380, but I'm using 500. I don't think I changed anything else here. I believe that's it for now. And well, you can turn the motor stop on if you don't want the motor to spin when you arm it. You can turn that on. Alright, so that's about it. Let's go ahead and save the changes. Next, let's go to the receiver tab here, and let's go ahead and turn on the Taranis radio.
Welcome to Taranis.
So turning on the Taranis radio, and we'll see if PPM works. Alright, let's see what we got. I'm going to move the throttle, and you'll see the throttle is moving the roll. Now I'm going to move the pitch. The pitch is moving the throttle, and when I move the roll I get the pitch. So you can see that isn't right. So what we have to do is go down here, and I'm going to select JR Spectrum. Now this will just depend on your radio. Just pick the one that works right for your radio, or change it in the radio itself. But I'm going to go with this since my radio is already set up. Now I'm going to save it. Okay, now we'll check it again. I'm going to move the throttle, and now the throttle is operating. And we'll do the pitch. Pitch is working. Roll is working. That's the aileron. Roll. Pitch is, of course, the elevator. And then we have the rudder, which is yaw. So all the channels are operating properly now.
So let's just run through the output pins on the BeeRotor. So these pins right here are actually just, this is voltage, 5 volts and ground. And I've got the 5 volts going to my camera right now. But these pins here are the output pins for the RC channels. The first one and the second one are the throttle channels. So you have a throttle channel on 1 and a throttle channel on 2. And then the next one, in my case, is the elevator. Then you got first aileron, second aileron, and then rudder on the 6th one. This whole row here is ground, so these outside pins are ground. So what I'm going to do is I'm going to hook the throttle up here to this pin right here, and then we'll go ahead and calibrate the ESC. Here's a diagram of the same header we were just looking at. I've got the 2 throttle channels labeled here, and then the elevator, the first aileron, second aileron, and rudder labeled right there. So here's my wire from the ESC right here, and I'm just going to go ahead and plug the white wire into the first pin on the BeeRotor. So we're just going to take that and plug it right in that first signal pin right there, like that. And then we're going to go ahead and calibrate the throttle with Cleanflight. So I'm going to go ahead and plug in the USB cable into the computer over here, but I'm not going to plug in the battery until we get to that point in the calibration for the throttle.
Okay, so back in Cleanflight we're going to go to motors right here, And what we're going to do is make sure there's no propeller on your motor, but go ahead and turn this on so that makes the motor active. And then bring the master all the way up like this. And then what we do is plug in the battery, and after it gets done, the motor gets done making its tones, or actually you don't have to wait for it to get done. When it starts making the tones, just drag this back down, drag the master back down. Well, here I'll just go and show you. I'll plug in the battery. Starts making noises. Pull the master back down. It beeps. You're done calibrating. That's all there is to it. Then you can turn this back off. Like that.
Okay, I'm going to go ahead and just turn on the Taranis.
Welcome to Toronto's.
Like that. And then we're going to give the throttle a little test. So I'm going to plug in the battery to the BeeRotor. Okay, there's the BeeRotor display coming up right there. Well, you can see it says disarm. Now when I move this stick over, see it says armed. Now we can run the motor. So that's basically how it works.
Okay, now that we've done that, let's go back to the PID tuning here. And we're going to knock these down quite a bit. A plane doesn't need the kind of responsiveness that a mini quad uses. So let's knock these down about half. I might make that about 2. And this one down 0.015, something like that. And this one, it's half of 23, I don't know. Let's go about 16, like that. And then just do that for each row here for pitch and yaw. And then go ahead and save it. Okay, so I changed the second row to be the same as the top. And then the third row I got 4.2 and 0.022. And this was already 0, so I just left it alone. So I'll just go ahead and save that.
So now I have this elevator servo wire connected to this third pin here for the elevator, and I've got it powered off the cable from the ESC right here. And you can see when I move the board up and down, you can see it's trying to move the elevator servo to compensate for that movement. That means the stabilization is on right now. So you can see that elevator is moving. Well, I still haven't covered flight modes or looked into RSSI, but I need to get this stuff off this board and into the plane and fly it. So that's my next move, to try to transfer it to the plane and get it set up in the plane. Here, flight.